Hello everyone and welcome to the hands-on demo on AWS Glue. So in this demo, we will set up Amazon S3 buckets and upload some sample data. We will create an AWS Glue data catalog. We will create an AWS Glue crawler. We will create an AWS Glue ETL job. We will run and monitor the ETL job. We will set up and use Amazon Athena to query the data. We will test the whole setup, and finally we will clean up all the resources. So this is the demo overview. So we have S3 bucket. So this will contain our source data, and there'll be a glue crawler that we will create, and this glue crawler will crawl the S3 sample data. It will identify the schema, then it will create a database and a table, and then that information will be saved in a Glue data catalog. Then we'll create a AWS Glue job which is in Python, and that Glue job will process the data. It will process the data in the sense it will refer the schema which is there in the catalog, which is kind of a metadata, and then it will process the data and it will do some processing and store back the results to the S3. And finally we will use Amazon Athena to query the processed data. So first step is to create S3 buckets. So I will create this particular bucket. So there will be two buckets. So this is the source bucket that will contain some sample data. So I'll copy the bucket name. I have logged into AWS console home and search for S3. So click on S3. Click on create bucket and paste the bucket name. And that's all. Create bucket. So all the settings are default settings, so there are no change. Keep the defaults. And next we will upload some sample data. So I have the sample data. So this is copy the whole sample data. So I'll copy it by clicking this button and save it to any to a text file, and you can use any editor. So I'm just using Visual Studio Code. So what I can do, I'll just copy paste the whole thing and save it. And so I'll just say create bucket again. So if you get some error, so probably this bucket name is already taken. So what I can do, I can add some number at the end randomly. So I'll just change one bit. So I'll just make it from 1 to 2 and click on create bucket. So the bucket is created. Now just let it come and click the bucket and click on upload. Click on add files, and I have saved that file to desktop and it's under Glue demo. So I'll copy the sales data.csv. And so sales data.csv is there, and click upload. So the bucket, the file is successfully uploaded. So just close this. So next I will create the second bucket. So I'll just call it my Glue processed bucket. So click on buckets and click create bucket. I'll paste the bucket name and click create bucket. So again this bucket name is already used, so I'll just add 2 at the end. So bucket names are universally unique, so if you get a conflict, you just change some number at the end or just put some random number at the end. So next step is to in the AWS Glue, so we have to create a database. So I'll search for Glue. I'll open AWS Glue in a new tab. So let it load. I will just copy the database name. So I am calling it sales database. So under data catalog, you will see databases, tables, connections and crawlers. So click on databases. Click add database, paste the name, and create database. So we have sales database now. Now we'll add a crawler. So copy the crawler name, click on crawlers, create crawler, paste the crawler name and click next. Now here you have to define that where are your data sources are. So in this case we'll say it's so all these options are there. So S3, JDBC, DynamoDB, DocumentDB, Delta Lake, Iceberg and Hoodie. So our data resides in S3. So I'll just say S3 in this account and browse S3. Select the source bucket because that's where we have saved the CSV file, and rest all options are fine. Click on add S3 data source, and then so this is custom classifiers optional. Click next. Now you have to create a IAM role. So this IAM role will be used to talk to S3 bucket and basically create a service role for this particular service, Glue service. So I have selected the source, and next I will create this IAM role. So copy the role name and create new IAM role. I'll paste the role name and click on create. So this is the IAM role. Now click on next, and for target database, select the database which we have just created, sales database. Rest all settings are default. Click on next and just review and create, and click create crawler. So we have seen this. We have added a role, we have selected the target database and review and create. So after that run the crawler. So you will be taken to the default crawler which you have created, and just click on run crawler. So when you run crawler it will go to your source database. It will see what kind of files are there. It will identify the schema and it will populate the database with a table. So successfully started the crawler. So it is started running. So this is the crawler runs, and it will take some time to get completed. So the crawler ran for around 1 minute 21 seconds, and then it successfully completed. Now I will edit the role which is attached to the crawler so that it can talk to the S3 bucket that I have created. So you have to go to AWS Glue service role sales demo and create an inline policy. So I'll search for IAM. So before I do that, I'll just want to show that where the table has been created. So if you just expand this and click on tables, you will see that the crawler, after scanning through the S3 bucket, has successfully created one table which the name is matching exactly with the bucket. So it has just replaced hyphen with underscores, and if I click the table name, you will see it has identified the schema also. Okay, back to IAM. So here I will go to the roles, and this is the role which it has created. Now I need to give permissions so that it can access the S3 bucket, the source bucket. So click inline policy and add this particular policy. So I'm saying, so this is the target bucket. So this is the process bucket. We have the source bucket and the process bucket. So basically I'm giving permission so that it can save the results back to this particular bucket. So I'll copy this whole inline policy and click on JSON and just copy paste the whole thing, and remember to to change the bucket name. So in this case, I just have to make one small change, make it from 1 to 2, and click on next. Give a name to the policy. So I'll just call it S3 write access. Create policy. So the policy has been created successfully. Next, what I will do, I will create a glue job. So this will be the job, and I will have the code. I'll just go to the glue service again, and under ETL jobs, so I'll just open this in a new tab, just in case I have to come back and show something here. So I'll open it here and click on this option, script editor, because I'll just copy pasting. I will be copy pasting the whole code. So we say author code with the script editor. You have other options like notebook. This is the interactive Jupyter notebook, and then you have visual ETL. So you can visually drag, pick and choose visual elements and create a workflow. So click on script editor, and engine is Spark, and start fresh option, and click create script. So other options are Python shell, Ray, and Spark. So this is the code. I'll show that in Visual Studio Code and explain the code as well. So this will be available in the resources section. So this code is a bit long. So what it is doing first is importing the necessary libraries, then getting the job parameters. So I'll be providing the input parameters like output bucket. So that will be the process bucket where the results are stored. Then I am initializing some Spark and Glue context. After that, I read data from AWS Glue data catalog, and this step fetches the data from the specified database and table in Glue data catalog. So it's finding out sales database and my Glue source bucket. So I'll just have to make this to 2 because the source bucket is just paste the whole bucket name. Then finally convert the dynamic frame to a Spark data frame for more complex transformations. Spark data frames offer a wider range of transformation operations. Then I'm doing some data cleaning and typecasting. So converting string columns to their appropriate data types. Then I'm calculating a total sale amount. So this will multiply quantity by price and round to 2 decimal places. So in our data, we have columns called quantity and price. So we are multiplying it and finding out the total amount, and then we are just rounding it to 0.2, like 2 decimal places. And this aggregation is categorizing orders by total amount, and this adds a new column, order size, based on the total amount. So based on the some column it's creating a column order size. So if the total amount is less than 20, so total amount is your quantity and price. If it is less than 20, it's small, otherwise 20 to 50 is medium, otherwise it's a large. Then there is a third, so this one is extracting month from date for our monthly summary. And this creates a new column month in the format of mm-yy. So it's finding out the month specifically, and then it's aggregating data for monthly sales analysis. So it is grouping by month and category, then calculating the total sales, average order value, and number of orders. So we have data frame group by month, then category, then we are aggregating based on total amount, and we are calling it total sales. And then we are averaging the total amount, and we are calling the one more column like average order value, and we are counting the order, the total orders count, and we are calling number of orders in that month. So when you see the results, it will become more clearer. And then we are aggregating data for customer summary. So this is the last one, like based on this customer profiling. So based on customer ID, we are finding out how much they have total spent and how much is the average spent, and based on the number of orders and the total amount. So we are, based on the customer ID, we are finding out this information. And this one is just making sure that because Spark will create multiple files, so we are saying coalesce to one file only, so that all the results are written to a single file. And this one is extra code for converting back to dynamic frames. So Glue uses dynamic frames for writing data, so we convert our Spark data frames back. And finally we are writing process data to S3. So there are total 3 aggregation. After I run, I will show you how it looks like, then it becomes much more clearer. And then we are writing the processed orders to this particular folder. So output bucket is same, but processed orders, there is one folder called processed orders and one folder called monthly sales and customer summary. So processed order, this folder, monthly sales and customer summary. And finally we'll commit the job to the Glue. So I'll copy the whole code and go to the Glue, and this is the script editor, and paste the whole thing and click save. So when you click save, it will pop up in the job details that you have to fill up some information. So I'll call this job sales ETL job. So name is mandatory, and then choose the IM role. So we have created this particular role. And lastly, we are providing some input parameter so that this job is much more dynamic. So this is job parameters, and add new parameter. So I'm saying output bucket. So paste the output bucket and paste the value. So I'll copy the bucket value, paste it, and make sure you enter the right bucket name, output bucket name, and that's all. Now click save. So the job is saved now. Now we will run the job. So on the same page, click on run and click on run details. So you will be taken to this third tab, which will be the runs. So every time you run, there will be a new run ID. So this particular job is running, and this is a managed, like serverless managed service. So you will not see any EC2. So this will be like serverless. So it will run, it will spin up some worker machines, and it will finish, and it will give back the results. So the job ran for 1 minute 31 seconds, and it has successfully successfully finished, I can say. And now we'll check out the output. So in our processed bucket, it should create some folder with the output files. So I go to S3 and go back to buckets page and click on processed bucket. So I can see there are 3 folders. So I'll check out customer summary. So there is a snappy Parquet file created. Now I'll check out the other monthly sales. So I can say there's an output file, but the file is in snappy Parquet format. So I'll use Athena later to read this whole file. We cannot open directly in a text editor. We need some kind of a Parquet reader. And the processed orders. So this is the processed orders. Next, we will use Athena to see our results. So first, we will create an external table, and this external table is basically pointing to our S3 bucket. So Athena has inbuilt capability to read Parquet file even if they are zipped, compressed as snappy. So I'll copy this whole query and go to Athena. I'll just search for Athena here. I'll open this in a new tab. So what I'm doing is just creating an external table, processed orders, and pointing to this particular Parquet file and creating the schema. So I'll just collapse it, and I'll close some of these tabs. I'll paste the whole query and make sure you change the bucket name and click on run. So this is successfully finished. So it has created an external table. So you can check out here. So processed orders. So this table is created. So now I'll just create the two more table, monthly sales. So you can just click plus over here and create this second table. Click on run. So this table is also created. And the third table, customer summary. So I'll copy the table name. Sorry, the whole query. Make sure I replace the bucket name. Click run, and this table is also created. So first I'll just check out the processed orders. So basically this is just saving as it is all the information from our CSV file. So if you scroll down, you can see the results. So it has order ID, the date, and so it's all falling in 1 month. So this is data is already the 10 records, and their customer IDs from 1 to 5, 01 to 05. Their product IDs, and there is some quantity and the price, and then it has created the total amount, order size, medium, small, large, and the month and category. So you will see in our source data, this information is not there. Some of the information is not there. So if I show you the source CSV file, so in source CSV file, we don't have these extra columns like, so you can see order ID, date, customer ID, product ID, quantity, price, and category. So we have 1, 2, 3, 4, 5, 6, 7 columns. But herein we have added some extra columns like the total amount, order size, month. There are 3 extra columns, right? So I'll take the second query now. So this is selecting monthly sales and then ordering by month and category. So I'll open a new tab here and paste the query. So it is taking month. So it's not taking the date part, only the month part, and which category they fall. And so there are 3 categories all in. So out of 10 records, there are 3 total category. Then it is finding out the total sales for books, clothing, and electronics. And then it's finding out the average order value. So order by month and category, and then the number of orders. So there are total 10 orders. So there are 3 in books, 3 in clothing, and 4 in electronics. And then total sales and average. So this average is basically total sales divided by number of orders. So I'll take the last query now. So this one is doing like customer summary. So it's saying customer ID, then how much they have spent, total spent, and it is from based on the descending order, like total spent is the highest, and how many orders they have placed, and what is the order value. So this is also simple, like total spent by number of orders, but we are arranging by from top to bottom total spent. So total spent is 109 for customer second, and same way it goes down. Okay, now we'll clean up all the resources. So we'll empty and delete the S3 buckets. So I go to the Amazon S3 buckets and click on buckets. So I'll take the first source bucket, and so I have to empty it before I can delete the bucket. So I'll copy paste this permanently delete and click on empty. Click exit, and now click on delete. And copy the whole thing and paste. Same way I will do for the processed bucket also. So I'll select this and empty it. So copy the permanently delete. And empty it. Exit and delete. So you can delete these two buckets also, Athena queries and AWS Glue assets also. So, but if you want to again refer back in Athena, this will not be. So if you delete here, all the objects will delete from the main Athena console also. So I'll just keep it. And Athena queries is basically used by Athena for its own background queries. So now I will delete the glue job. So if I go to the runs and sales ETL job, so you can come here, or you can go to ETL jobs, and if you click on, so just refresh here. So select the job and actions, delete job and delete. So the job is deleted, and next is to delete the crawler. So go to the crawlers and you can just click on delete here and delete. Next is to delete the database. So I am here, and so I just go to the database. So if you click the database, tables will also get deleted. So select the sales database and click delete. So the sales database is deleted. Next, delete the IAM role. So go to IAM. So under roles and this particular role, and click on delete. So copy paste the whole name and click delete. And that's all. Thanks for watching.